So this is the 2017 AS depth paper. It says a student was asked to carry out an experiment to determine the initial rate of reaction of zinc and hydrochloric acid. The student plans to collect a total of about 72 centimetre cube of hydrogen at room temperature and pressure, and to use an excess of zinc. The student selects the following apparatus. The apparatus is revealed in the diagram with a 100 centimetre cube gas syringe, a stop clock, 2 decimal place balance, and a 100 centimetre cube measuring cylinder. Okay, so whatever volume you have, it cannot be over 100 centimetre cubed, and whatever volume of gas you collect, it has to be less than 100 centimetre cube gas, but we know we're only collecting 72, so that's why we're using a 100 centimetre gas syringe. Outline how the student would carry out the experiment and explain how the results could be processed graphically, show all working in your calculation. So we start off with the method. Okay, so start by what you would measure out, so the zinc, measure the mass of the zinc, so be specific, measure the volume of hydrochloric acid, mix them together in a flask, and measure gas at time intervals. Okay, so that's the method. How do you do the calculation? Well, you know you are going to collect about 72 centimetre cubed of hydrogen. So what's that in moles? So V over 24,000, so 72,000 over 24,000, we're going to collect 0.003 moles of hydrogen. Down here is a balanced equation, so you need to be able to do that. Remember, zinc is Zn2+, you need to know that one. So the ratio of hydrogen to zinc is 1 to 1. So if you have 0.03 moles of hydrogen, you've also got 0.03 moles of zinc. So how much zinc do you need? What's the minimum mass of zinc do you need to make 72 centimetre cube gas? So mass is Mr. Moles, Mr times moles. So Mr of zinc times the moles of zinc, we need 0.28 grams of zinc. Okay, so we also can work out the moles of acid that we need, but that doesn't really tell us the measurement, so we need to convert that to a measurement. So because it's a solution, we're going to convert that to centimetre cubed volume. So remember, volume is moles over concentration. Well, we know the moles, 0.006, but we don't know the concentration, so you have to decide a suitable concentration. We're working ones, so let's start with 0.1 mole per decimetre cubed. So if we use that, and you do moles over concentration, remember you'll get your volume in decimetre cubed, so times it by 1,000 to get in centimetre cubed, you get 60 centimetre cubed. How big is our measuring cylinder? 100 centimetre cubed, so that's an appropriate concentration. If you use 1 mole per decimetre cube, you end up with a volume of 600 centimetre cube, and that's too big. Then how do you process your results? So you need to plot your graph, so your volume versus time, do the tangent at t equals 0, do the gradient to find the initial rate. The gradient is y over x, so your volume over time. You also have the volume changes over time, so volume will be your y-axis. Okay, so that's that.